Okay, so this is going to be our last video dealing with exponential growth and decrease problems. So we use this formula: A is equal to P times 1 plus or minus R to the T power. Okay, just like we did in the last video, where A is your final amount, P is your initial amount, R is your growth rate or decrease rate, and T is your time. So let's jump right in. Bacteria can multiply at an alarming rate when each bacteria splits into 2 cells, thus doubling. If I start with only one, golly, I have errors everywhere. One bacteria, which can double every hour, how many bacteria will we have by the end of one day? Okay, so if I start with 1, it doubles, right? So if something's doubling, that means the rate, your growth rate is 100%. Okay, so 100% is going to be 1 plus 1, which is 2 to the T power. Now, this is going to be, it splits into 2 new cells every hour. Okay, so how many hours are there in a day? Well, there's 24. So 2 to the 24th power is this. So one bacteria that doubles every hour is going to give us this many bacteria by the end of the day. So 167,77216 bacteria. Okay, it says the population of Winnemucca, Nevada can be modeled by the following equation, where T is the number of years since 1990. What was the population in 1990? Okay, so the population in 1990 is your initial population, so it's going to be this number right here. So population in 1990 is 6191. Okay, it says by what percent did the population increase by each year? Okay, so remember, in our formula up here, it's 1 plus R. Okay, so your R is going to be 1.04 minus 1. Okay, so it should be 4%. So what percent did the population increase by each year? 4% increase. And that's all this question is asking. So to get your percent increase or percent decrease, do 1 minus whatever's in the parentheses. Okay, next example problem. It says your savings account is growing at a rate of 3.2% per month. How long will it take your account to triple in size? Okay, so A is equal to P times 1 plus R to the T. So to triple, it's 3 times the initial amount. And it's growing at 3.2%. So this will end up canceling. The P's will cancel. You can pick some arbitrary numbers. You could have started with $100 and put 300 here. It'll still work out the same exact way. Okay, so 3 is equal to 1.032 to the T power. Anytime I'm trying to solve for a variable in the exponent, I'm going to natural log both sides. So we get natural log of 3 is equal to T natural log of 1.032. So natural log of 3 divided by natural log of 1.032 is 34.88 months. So a little less than 3 years. Okay, last question. It says you buy a new computer for $2,100. The computer decreases by 50% annually. When will the computer have a value of $600? Okay, so A is equal to P times 1 plus R to the T power. Now, since it's decreasing, we're going to use a negative. Okay. We'll use our negative. So our final amount, our final value is 600. Your initial amount is 2100. It's decreasing by 50% annually. So we're going to do 1 minus 0.5, which is going to be 0.5 to the t power. Okay? So remember, we're going to isolate the exponential first. So you have to divide both sides by 2100 first. The two zeros will cancel, so you get 6 over 21 is equal to 0.5 to the t power. Solve for t in the exponent. We're going to natural log both sides. And then we're going to divide both sides by natural log of 0.5. So natural log of 6 over 21 divided by natural log of 0.5, sorry. And you get 1.807. Okay, and this makes sense because if I do 2100 and I divide it by 2, it's decreasing by 50%. It has a value of 1050. If I divide that again by 2, it's 525. So I'm trying to figure out where it's going to be a value of 600. So after 2 years, it'll be down to 525. So it's almost there. Okay, so our number does make sense. Hopefully these example problems helped you out a little bit. You'll have 2 worksheets to go with these example problems during the week. And if you have any questions, feel free to reach out. Thanks. Bye.